In this video, we want to evaluate this integral from 0 up to pi over 2 of this function here involving sine and cosine, and then we do that with respect to x. Okay, how I wish it was with respect to y. We will just treat this as a constant and we will do it fast. So how do we do this? Well, like I said, this function is made up of sine and cosine, and this interval from 0 to pi over 2. You know that sine of pi over 2 minus an angle is cosine of that angle, right? Like sine of 30 is cosine, the same thing as cosine of 60. That is going to be helpful. I'm saying that because I've tried it already, alright? I've tried it already. Yeah, it's a very powerful tool. Anyway, in one of my previous videos, I did something like that. We had the integral from pi over 6 to pi over 3 of sine raised to the power of cosine raised to the power of sine, and so on and so forth. That is infinitely nested powers of sine and cosine alternating. And when we did that, somehow we were able to, get something out of it. So let's just do the substitution and hope for the best, all right? Like I said, I've already tried it after trying a lot of other things anyway. So let's see what we'll get. So this is, we say let u, right, be pi over 2 minus x. So this is the substitution we're going to start off with. Okay, and that is when we add 0 to pi over 2, we just get pi over 2. Then we subtract the angle x from that. So let's differentiate this to see what we have. The derivative of u with respect to x will give us negative of dx, right? Because x is just a single term there. Okay, so let's see. This will become the integral. Well, when x is 0, u will be pi over 2. Okay, when x is 0, u will be pi over 2. And when x is pi over 2, u will be 0. Okay, and then we have the square root of sine of x here. That will become the square root of, let me put the fraction here, the square root of sine of x. Well, you notice that since u is pi over 2 minus x, x will be pi over 2 minus u, right? So we put it here. Okay, then we said divided by the square root of, similarly, this will be sine of pi over 2 minus u, okay? And then we are going to add it with the square root of. Okay, great. Well, we know that from the property of sine and cosine, which are co-functions at complementary angles, that sine of 90 degrees minus an angle is the same thing as cosine of that angle u, right? So using that fact, that means we are going to have this to be the integral. Oh, this is dx. Let me replace it with du, right? So that we can use it to switch this. Notice this is negative. When you put it, you're going to have negative du, right? So we have negative du here. Well, we are going to use this negative one to multiply with, to change this bounds of integral, right? Switch them. That means we're going to have the integral. Instead of this to that, we're going to have from 0 to pi over 2. Okay. We've used up this negative sign, so we won't see it again. So from what I said earlier, we're going to have this to be the square root of, well, sine of 90 degrees minus an angle is cosine of that angle. And that angle here is u, right? Not u, like u, the alphabet, the English alphabet. And then we have the square root of, right? Okay, that's nice. So let's see what we have from there. Well, I would like to do the thing here. I would like to call this integral, this given integral, let's call the whole of that, let's call it just I, right? We call it I. So you notice that this right here, since this is equal to this one, and this is equal to that, that means this is still I, right? So we can still take note that this is still I. Just the name we are giving to the integral. There's a reason for that. Well, I want you to know this, or to remind you, whichever way. This is u, right? Du, and then it starts from 0 up to pi over 2. Well, when we are doing a definite integral, the variable here is considered as a dummy variable, all right? What that means is that I can use u, I can change it to x like this. I can just clean this u and change it to s. I can just change it to t, anything I want, including this one. They are just dummy variables, right? U and x. So we can switch it to whichever one we want it will not change the value of the integral, right? So that's exactly what I'm going to do here. So you notice that, for example, now let's say we want to integrate this function, let's say from 0 to 1 of let's say 3x squared dx, right? Integrating this, we'll just have x to the third power from 0 to 1. Substitute 1 and substitute 0, the answer will just be 1. Change this to y, that'll be y here, right? If I change this to y, substitute it, it's still 1. So the x and y or u doesn't matter because we're dealing with definite integrals. They are just dummy variables. They will not change changing them will not change the result of the integral. Okay, so what that tells us is that this, where I used u, I can change it to x anywhere. All right, so I and I, let's say we want to add these two equations together. Two equations, yeah. This is I equals to this, and then I equals to this one, right? So adding them together, we're going to have 2i. And then that will be equal to, well, we are going to add the two integrals as well. That means we're going to have the integral, take note from the same bound, so that is nice. Okay, and then over the same variable. Let me change it to x as well. So that will be, so we are going to add this and that together. You know, you keep in mind that these denominators are the same. This is cosine plus sine, square root of each of them, and then the square root of each of them. So since the denominators are the same, we can maintain a single denominator, sine of x, plus the cosine of x, okay, under the square root. And then we're going to add the numerators, which is just square root of sine of x, okay, plus the square root of cosine of x, and so on and so forth. Okay, that's all. Anyway, so take note, this is going to become, well, 2 times the integral, right? 2 times I equals to, well, the numerators and denominators turns out to be the same after adding the two integrals. So that means we're going to cancel them. We're going to have 1 here, right? So we're going to integrate 1 from 0 to pi over 2 over the x variable. That means we are going to be having x from 0 to pi over 2. Okay? So this means that this integral I will become 1 over 2 of this 1/2 here. We substitute pi over 2, we have pi over 2, minus we substitute 0, that will just be 0. So everything becomes pi over 4. And that is the value of I, which is the integral we're asked to find, right? Okay, I did not mention from the beginning of the video, we are going to be doing 2 integrals here. So this is the first one, right? Pi over 4, right? So let's just get on to the next one. And then this one really requires a lot, so you will see. Here we are not having from 0 to pi over 2, but rather it's from 0 to pi. But we can still use the same kind of technique, the same kind of, work, right? So it's more like killing 2 birds with one kind of stone, not one stone, but one kind of stone. So let's just do a similar substitution. So as you guess, we are going to add these two bounds together, and then we are going to subtract x from that, right? So we say let say u to be this plus that will give us pi minus x, right? Okay, so we differentiate that to get negative dx, right? That's not bad. So when we do the substitution, we are going to have this to be, maybe I should also remember to give this a name. I'm going to call it I, right? Okay, so this is going to become the integral from 0 up to pi, the integral. Notice that when x is 0, pi u will be pi, right? Because we are going to change that from x variable to u variable. So we also change the bounds as well. And when x is pi, u will be 0. This is x, where x is pi minus u, right? So we have this to be pi minus u in place of x. Then sine of x. So sine of x will become sine of pi minus u, right? And then we divide that by 1 plus the square of cosine of x, which is pi minus u, right? So we subtract u from pi, and then the dx is going to be negative du. So let me just put the du here, the negative du here anyway. Okay, so you notice that this is not really good, so we are going to use this negative sign to correct that. That will become the integral from 0 up to pi, right? So we've used this negative. All right, great. And now let's see. Well, notice that this is pi minus u. Now notice that sine of 180 minus an angle is positive sine of this angle, right? Yeah, that is true. Sine of that will give us positive sine of this angle, which is u. Okay, whenever you subtract, let's say the angle is in the second quadrant and you subtract it from 180 degrees, the result will be the same thing as sine of that angle, right, in the first quadrant. Okay, so check that out. That is correct. Or you can just use a sine of double angles or sine of difference of two angles, right? When you use that identity, that will be sine of pi, which will be 0, then cosine u, then you subtract sine of u, then cosine of pi. Cosine of pi is -1 times the negative you subtracted, that will become sine of u. That's correct. Okay, so we have 1 plus cosine of this will also work similarly, because that this one will have a negative, but this square is going to correct that negative, so we're going to have cosine squared of just u, right? This would have been negative, but the square will correct that. Okay, and we put the du over here. Remember, the negative sign was used up. So here, what I'll do here is to split this. Okay, so let's just take it from here. I'm going to split this. That will become, that means that I will become this I here. All right, so you take note that is the I we are using throughout. I will become, well, when we split this, we're going to have pi times this, right? So maybe I can put the pi outside. We have the integral from 0 up to pi of sine of u. All right, we divide it by 1 plus the square of cosine of u, and then du. And then we also, I think I really like x too much. We subtract, by splitting, we're going to subtract the integral of this. That will become minus the integral from 0 up to pi of u times that, right? That will be u times the sine of u, divided by 1 plus the square of cosine of u. And we put the du over here. So where do we go from here? Okay, again, like we discussed previously, that this right here is a dummy variable because this is a definite integral. Same thing with this u. So maybe I can change from u to x, change from u to x, change from u to x, all right, and change from u to x. So when we do that, you notice that this right here will be exact same thing as the I, this I here. That is the integral from 0 to pi of x sine x divided by that. So in fact, I'm going to call this one I, okay? So I will call that I. That means you're going to have to subtract that. So it's going to be I equals to pi, then the integral from 0 up to pi of, okay, minus I, all right? So this is the minus sign. This is that, which is the original thing. So we are going to add I to both sides, which will be 2 times I of that. 2I equals to that, right? Well, what is this one? How can we help ourselves with this? Well, let's see. This right here is not the same thing as that. Take note, there is no u here, so we cannot do that. So what do I do? Well, we are going to do a u sub. I'm going to start by saying let u. I already used u, but it doesn't matter because I've not changed it. Anyway, let's use t. So we say let t. Okay, we want to do a t sub. So let t be, I will let t to be cosine of u. So letting t to be cosine of u, if you differentiate that, we have the t to be negative sine of u, all right? And then we can put the du over here. Take note, adding these two together, we are going to have 2i, right? To be, well, this is pi outside the integral. We have the integral from 0. Well, when u is 0, what will t be? Cosine of 0 will give us 1. And when u is 1, when u is pi, t will be what? Cosine of pi will give us -1. From 1 to -1 is not good. Let's say, hopefully, we are going to change the order. Of course, this negative will help us. So we have sine of u, right? Sine of u is here. Sine of u du. So maybe if we multiply this by a negative sign, and also balance it by multiplying outside by a negative sign, that means you're going to have a negative sign here. Negative sign u du will give us the t at the top. Let me put it in blue to show you just coming in. The t at the top, okay? We divide it by 1 plus cosine squared of u. That will be 1 plus t squared, all right? Okay, that's nice. So this negative will be used to change the order, the bounds of integration. So we're going to have this to be pi times the integral from 1 up to -1 of dt divided by 1 plus t squared. no, from negative 1 to 1, okay, this negative will help us to switch the bounds of integration. Now take note that this is 2i, alright, 2i equals to, well, we are going to have pi times, what is the integral of the t divided by 1 plus t squared? Well, the result is just inverse tangent of t. Inverse tangent of t. So that's exactly what I'm going to put down here. We're going to put down inverse tangent of t, right? And t is to be taken from negative 1 to 1. Okay, so we're going to substitute 1 and then we substitute negative 1 and hope for the best. So do I still have, okay, I still have a little room here. Maybe we're going to clean it a little bit. Okay, maybe let's just do it here. Pi times, well, when we substitute 1, inverse tangent of 1 will just give us pi over 4. So you keep that in mind. Minus negative 1. Substitute negative 1 into here. Inverse tangent of negative 1, of course, will give us negative pi over 4 because this is just an odd function. So negative pi over 4, negative pi over 4, that will become positive, right? Because there's a minus waiting for the negative pi over 4 here already. So all in all, we have 2i, okay, to become pi over 4 plus pi over 4, that would just be pi over 2. Okay, that will become pi times pi over 2. So of course we can just finish this. Yeah, so maybe I'll just give this to you, put the end, the answer should just be pi squared over something. So you can finish that off. Or anyway, that is going to be the result, pi squared over 4. Thanks for watching, and I hope you enjoyed this video. Right? That was a lot, wasn't it? Anyway, I'll see you in the next video. Please subscribe to my channel. And thanks for subscribing. Alright? Yeah, thanks for subscribing, and I'll see you in the next video.